In this video, we're going to talk about the chain rule. So far, with derivatives, you've learned how to differentiate a whole number of functions. However, none of the derivative rules that you've learned so far would allow you to differentiate a function such as this, the square root of the polynomial x squared plus 2x minus 4. You can differentiate the square root of x, and you can differentiate the polynomial. But the chain rule is used to differentiate composite functions. That is, when you have a function inside of another function, the chain rule is used in conjunction with the other rules. And this will allow you to differentiate just about any function. So we're going to look at the y(u)(x) version of the chain rule. So if y is a function of u and u is a function of x, that is, y is a composite function of x, then dy du is the derivative that represents the rate of change of y with respect to u, or another way to think of it that makes more sense in this context is that dy du represents the ratio of a change in y to a change in u, right? Or du dx represents the ratio of a change in u to a change in x, and dy du represents the ratio of a change in y to a change in x. This notation, the dy dx notation, as opposed to the f prime of x notation, is useful because it is a fraction, and a fraction is a ratio. So it can be used and thought of in these different ways. So for a simple example here, let's suppose that Yancey, Yuri, and John, notice the first letters, y, u, and x, okay, are picking apples. So we're going to let y, u, and x represent the number of apples picked in some period of time by Yancey, Yuri, and Jean, respectively. Yancey picks apples 3 times faster than Yuri, which means that the rate at which Yancey picks apples with respect to Yuri is 3. So dy du is 3, because Yancey picks apples 3 times faster. So the ratio of a change in y to a change in u is 3. Yancey's picking apples 3 times faster. Yuri picks apples twice as fast as Jean, so the ratio of the change in u to the change in x is 2. So du dx is 2. Okay, so Yancey picks apples 3 times faster than Yuri, and Yuri picks apples twice as fast as Jean. So Yancey picks apples at a rate that is how many times greater than Jean, right? You can imagine if Jean picks 1 apple, okay, just to put a number on it, and Yuri picks apples twice as fast, then Yuri's going to pick 2, right? But Yancey picks apples 3 times as fast as Yuri, so Yuri's going to pick a total of 6. Okay, in other words, dy dx, the rate at which Yancey picks with respect to Jean, or the ratio of the change in y with respect to x, it's equal to the product of the rate at which Yancey picks with respect to Yuri times the rate at which Yuri picks apples with respect to Jean, or in other words, 3 times 2. So Yancey picks apples 6 times greater than Jean. It's the multiplication of those first 2 rates. So the chain rule in these terms says that dy dx equals the product of dy du times du dx if y is a function of u, so y equals f of u, and u is a function of g. Okay. Another way of stating the chain rule is like this, that dy dx is equal to f prime of g of x, because g of x could go right there, times the derivative of g of x. Okay. I'm not going to focus on this notation in this video. We're going to focus on this dy dx notation in this video. Although either way you'll get the same answers. So let's look at this example right here. So suppose that y equals u cubed and u equals 2x plus 1. We're going to find dy dx, that is the derivative of y with respect to x, 2 ways. First, we're going to use the chain rule, and then we're going to sort of prove or show that it worked by first actually getting y in terms of x and just differentiating it using the rules you already know. So first, supposing, let's see, right here, chain rule, that dy dx, by the chain rule, if y is defined as a function of u and u is defined as a function of x, then dy dx is defined as dy du times du dx. So dy du, that's the derivative of y with respect to u. That's this right here. Using normal power rule, that's 3u squared. And du dx, that's the derivative of u with respect to x right here. The derivative of 2x is 2, and the derivative of 1 is 0. So then dy dx is their product, okay? By the chain rule, dy dx is defined as the product of this and this, dy du times dy dx. So 3u squared times 2. Now we want to put our derivative, however, in terms of x because that's what we're finding, dy dx. So we need to replace this u by what u is equal to in terms of x. U is equal to, in parentheses, 2x plus 1 all squared times 2. Or if you want to simplify, you can multiply the 3 times 2, but that's all I would do right there. So that's with the chain rule. Okay, let's check it by first getting y in terms of x. So y is defined as u cubed, but u is defined as 2x plus 1. Now the reason we have the chain rule is because you can't always simplify a function, but when we have something cubed, it is possible to multiply all of that out, right? That means 2x plus 1 times 2x plus 1 times 2x plus 1. So I'm going to, we could use the product rule. I think it will be easier to expand it first, however. So I'm going to multiply 2 of them, the first 2 together in the next step. So 2x times 2x is 4x squared, plus 2x is my outside term, plus another 2x is my inside term, gives me 4x plus 1. Okay, then when we have a trinomial, that is the first factor has 3 terms, times a binomial, how the second factor has 2 terms, we multiply each term by each term. So I'm going to start with the 4x squared and multiply it by each term in the other factor. So 4x squared times 2x is 8x cubed, and 4x squared times 1 is positive 4x squared. Then 4x times 2x is positive 8x squared. 4x times the 1 is positive 4x. 1 times 2x is positive 2x. And then lastly, 1 times 1 is positive 1. So let's combine like terms, and this is just y. I haven't differentiated. Then we'll differentiate using the power rule. So 4x squared plus 8x squared is 12x squared. 4x plus 2x is 6x, and then plus 1. So its derivative, I'll just write y prime here, is by the power rule 24x squared plus 24x to the first plus 6. Let's come back over here and simplify, not simplify, but expand this a little bit. 2x plus 1 all squared, I just did that right here, is 4x squared plus 4x plus 1. Distributing the 6, I do get the same thing, 24x squared plus 24x plus 1. So you can see that it does work. Now, if I were doing this problem, however, using the chain rule, I would actually stop right here. That would be my final answer. Next, let's look at what happens when we have, generally, when we have a polynomial to a power. This is often referred to as the general power rule. Here, y is defined as a function of x. Now, you could go in and say, let u equal the inside function. So let u equal 4x minus 5. Then y would be equal to u squared. And you could work it the exact same way we did this derivative, right, with y as a function of u and u as a function of x. So if you want to do it that way, All you have to do is to find u to be the inside function. Okay, but the same thing happens every time we do this. Okay, so let's do this the u way first, and then we'll look for the pattern, okay, so that we don't have to always bring in a u and write it out, because the same thing happens every time. So by the chain rule, we need to find du dx and dy du. Du dx is the derivative of this is 4, and dy du looks like 2u. So their product is dy dx, which is 2u times the 4, or 2 times 4x minus 5 times the 4, or 8 times 4x minus 5 when you simplify. Okay, I want to take a look at the unsimplified versions right here, and also in the previous example right here. Okay, we'll come back to that one. So what's happening is the power on the polynomial is coming down out to the front, is that 2 right there. Okay, and then the power is being reduced by 1, just like with the regular power rule. You bring the power down out front, and the power reduces by 1. Except that instead of having a plain x to that power, the inside function, that polynomial, stays put. And then by the chain rule, we multiply times the derivative of that polynomial, right? The derivative of 4x minus 5 is 4. Okay, let's look at this one up here. So in this one, the 3, right, that cube, comes down out front, and the power reduces by 1, so now the power on the 2x plus 1 is 2, and it's times the derivative of 2. This might be easier to look at, though, if I actually write out y as, actually, let's look at it right here. Here's y as a function of x, okay, and here's its derivative. So that 3 came down out front, right, down out here, then you have 2x plus 1 to the squared power. We reduce the power by 1, and then times the derivative of that inside polynomial, 2x plus 1. That's the general power rule. Okay, so what it says is if y is a differentiable function of u, and u is a differentiable function of x, then y equals u to the n, and y equals u to the n power. So you have really anything to the nth power. It doesn't just have to be a polynomial. What happens is that power comes down out front. You keep that inside function right there. You reduce the power by 1, and then you multiply times the derivative of that inner function u. So that is the general power rule.